Hello, my name is Omid Faghi, and today I'll be presenting my final project on antibiotic resistance and its threat to modern society. To start, I just want to explain the purpose of this whole presentation, and that is to just first off explain the general properties of antibiotics, and then knowing what antibiotics can do, I'll show the two major uses of antibiotics. And after you kind of can understand a picture of what antibiotics do, I will then emphasize the threat that antibiotic overusage can have on our modern society. And then I will outline the potential ways that we can reduce this threat, which is antibiotic resistant infectious bacteria. Let's begin. Antibiotics. Antibiotics are a tool designed by humans that essentially utilize the differences between humans and bacteria's metabolic pathways. And so what this means is that suppose both humans need to synthesize compound 3 to survive. Let's say it can be like cholesterol, for example. There could be two pathways that have evolved through time differently. And so suppose there's a human pathway and a bacterial pathway. What antibiotics can do is that they can act on a single, they can act on the bacterial pathway only. They can disturb that pathway, and they can change that pathway so that a different thing is created. And in this case, they can turn this compound B into something toxic. And since this is only affecting bacteria, both human and bacteria, if a human consumes an antibiotic, just the bacteria will be affected and the human will be okay. And so if the bacteria is producing this toxic compound, it will then essentially be committing suicide, and we will then have killed the infectious threat. The nice thing is that humans, we can just kind of flush out anything that, any of these little toxic compounds, because it's not a threat to our whole system. And so now that you can understand that antibiotics utilize very specific mechanisms of action, it's very hard to discover these kinds of things because we don't really know all of these pathways and all these different things. And so in order to be really thorough to design antibiotics, we need to have a solid understanding of essentially every pathway in both organisms. And so it kind of comes that drugs, rather than like us finding and designing antibiotics, the way we discover drugs is by random screening, where we just have a huge catalog, a database of compounds that we then screen against parasites and whatnot, and we figure out, oh, this specific compound is killing these bacteria way more efficiently than all these other ones. At a very low concentration, it's causing lethal effects. And so the idea is that once we figure out that it works, it's easier to figure out how it works then. Because then there's a lot of tests we can kind of do to figure out like what pathway it could be doing just by chasing how the bacteria is synthesizing the compounds we give it. And so all I just want to emphasize here is that antibiotics are very specific and they're very hard to discover, and it will take a lot of research to do it because there's a lot of compounds to screen and it's very hard to even figure out where it is, but it's possible. And so with this, I want to move on to the threat of antibiotic resistance and how it's generated. So antibiotic resistance is generated by selective pressure. And all this means is that suppose in your body you're dealing with some sort of bacterial infection. When you are given antibiotics, you are essentially putting pressure in your body against the bacteria. You're putting it in a harsh environment, and this harsh environment makes it hard for bacteria to live. And so any bacteria that's stronger than the other ones is more likely to survive and then repopulate your whole body. So the idea is that there's a selective pressure of the antibiotics, and if like a bacteria happens to survive in there, that's when it is considered antibiotic resistance. So now let's discuss how you generate this fitness advantage of being able to survive in this harsh environment. So the first way is through mutation, and this just happens when DNA is randomly altered or mistakes are made when the bacteria is reproducing. And it's said that 1 in 10 million bacteria can spontaneously generate an antibiotic resistance. And so the idea is that when you're giving body antibiotics, there's a chance that one of them happens to have the correct mutation to be resistant. And so what this kind of mutation is that suppose it creates a new protein that turns this toxic compound into compound 3 that we discussed earlier. If this happens, then there's no longer a dead bacteria because there's no longer a lot of toxic stuff in the bacteria and it survives. If the antibiotic's no longer hurting it, it will repopulate your whole entire body and it'll be like the antibiotic's not even there. Or even another example could be if it converts compound 1 directly into compound 3, then this whole entire other pathway that we discussed just goes away. And then it's like the antibiotic's not even doing anything. And so the idea is that this random mutation can occur, and whenever someone's being prescribed antibiotics, there's a chance that it could spontaneously create antibiotic resistance. And this is all under the assumption that the pressure is not enough to kill or is not lethal to bacteria. And so the second way is that once a bacteria is considered antibiotic resistant, it can pass the whatever gene that confers resistance to another bacteria, or anything that comes after, like after reproduction wise, down its family line, or it can just pass down the antibiotic resistance. And so a really scary threat is that as soon as one bacteria becomes antibiotic resistant, it can be common that every other bacteria nearby it can become antibiotic resistant and continually down time. And so essentially we will be losing drugs as time goes on because antibiotic resistance won't just go away. It will just stack on top of itself. And now that I have covered how antibiotics generally work and what antibiotic resistance is, I just want to go into the two major ways of how antibiotics are used in modern society. So first, there's antibiotic use in a clinical setting, and this is when antibiotics should be used to treat patients. And the idea is that if a patient has a life-threatening bacterial infection, then that is when antibiotics should be prescribed. For example, tuberculosis. There are a lot of bacterial diseases are constant threats to our society, and tuberculosis is something that is still a threat. 9 million people contracted TB in 2013, and 1.5 million died from TB-related deaths. So in 2013, and so the point being that this is still a relevant thing that is still costing us lives, and so we do need better antibiotics. And these stats are from the CDC. The second time you probably need to use antibiotics in the clinical setting is in the presence of any surgery. It's known that whenever you are operating on someone, any open tissue that is seen or exposed to air is extremely susceptible to infection. And this is because that unlike other areas of entry to your body, like your mouth or your stomach for digestion, there aren't like enzymes ready to fight off pathogens. So open tissue means you will be given antibiotics. Even for dental work, they'll essentially have antibiotics. And so these are the two main times you'll see antibiotics being used. But now time for the less fortunate antibiotic misuse in the clinical setting. As I mentioned earlier, antibiotic resistance occurs when there is anytime bacteria is under selective pressure of an antibiotic. And so the idea being that overprescription of antibiotics can by physicians will lead to an increase in antibiotic resistance infectious bacteria. And so if you have a non-life-threatening illness or infection, you do not need an antimicrobial prescription. You do not need antibiotics. And so the idea being, if you come into doctor with a cold or something that if you just wait 4 days and sit in bed and you'd be over, those are the times when you should say, hey doctor, no, I do not need an antibiotic. I am just going to chill out. The next misuse would be when patients don't follow antibiotic instructions. And the two most common things are when patients will drink while they are taking antibiotics. Drinking alcohol, that is. Drinking alcohol will nullify the effects of antibiotics for the duration that the ethanol is in your bloodstream. And so I was mentioning earlier that when you have antibiotics, you have that selective pressure on, when you put in alcohol, you kind of relieve that pressure and make it easier for the bacteria to survive in the presence of dilute antibiotics. And so that can kind of help lead to resistance. And the second thing is when you don't finish the full course of antibiotics. And the idea behind both of these is that you are not fulfilling 100% kill rate of your bacteria in your body. Just by leaving a few alive, by not being diligent to finish the full course, can mean that few can survive to be resistant and live on your body and or be passed on to other people. And it's just any presence of antibiotics is a environment for selective pressure and therefore antibiotic resistance. And I just want to make an interesting statistic was that again in 2013, over 300 million antibiotic prescriptions were made in the United States. And this is especially interesting to note because there's only 300 million people in the United States. And so this statistic is that roughly on average, one person would be prescribed an antibiotic per year. But it's also common that one person would be prescribed 3 or 4, and some none. But that's a lot of antibiotic prescriptions, and it's pretty safe to say that not all of these are life-threatening infections. Next, antibiotic misuse in the agricultural setting. See, for the clinical setting, I had a proper use, but for this agriculture setting, there really isn't a need for antibiotics. Sure, there's a need for antibiotics in the veterinary scene, but in terms of agriculture, the whole entire reason antibiotics are even used is for the concept that you can make more money in less area. It's not something that's a necessity, it's just something that is used for an economic gain. And so I just want to go into how antibiotics are used in agriculture. They're used by a small dosage of antibiotics in animal feed increases animal growth rate. And so the idea is that when you give your livestock a little bit of antibiotics, you'll increase your production of meat per animal. And then once again, more production per animal means more money. And that's what it's being used for. The next thing is that if you put in these antibiotics into livestock feed, it allows these animals to live in unsanitary conditions since they're already being treated for infections. Rather than having these animals live in an actually sanitary area, it's essentially being treated as, rather than treating the infection, we're going to treat their environment and just let the environment continue to go on. And the idea is that once they have more animals in a smaller area, they increase the quantity of animals and therefore increase the money they can harness. And this is all really, really scary because, as I mentioned earlier, anytime you put antibiotics into an environment, you allow antibiotic resistance to occur. And not only are we putting antibiotics into the environment, we're putting dilute antibiotics into the environment. And so any of these antibiotics that go through the animals and comes out as sewage will go into our natural environment, and any bacteria out there that survives, which is now not just a bacteria in your body, but a huge range of bacteria, they can all have the chance of generating antibacterial resistance. And so the old phrase, what doesn't kill you makes you stronger, is about to be shown across the world. And this is a huge threat because, while sure, some of these bacteria that might be dealing with these antibiotics are not threats to humans, some definitely are, and some that might not be human specific can species jump to become human specific. And so this is a huge threat, and it's just a very scary thing that we need to consider. And so some statistics now I just want to show to explain this antibiotic misuse is that 37 million pounds of antibiotics are produced per year in the United States for human and non-human purposes. And this is to keep in mind that antibiotics, these are small little pills that don't weigh very much. This is a lot of antibiotics. And the scary thing is that 30 million pounds of this goes to livestock feed, meaning that only 7 million go for actual human purposes. And as I stated earlier, I don't really believe that there is a just use for antibiotics in the agricultural system. If we had more sustainable and more healthy living conditions, we can help avoid this daunting threat of antibiotic resistance. Next statistic, I want to just say that there's 2 million people infected with resistant bacteria in the United States per year. and at 23,300 of these individuals died with no oxygen. So these are people who have a very common illness like a common cold or an STD or something like gonorrhea or chlamydia or something like that, and it just was resistant to every single antibacterial drug, and so there was no option essentially. And so now I want to go into why I believe this is such a threat. The reason why I'm so scared about this topic is that more bacteria are becoming antibiotic resistant and multi-drug antibacterial resistant, and we are not making enough new antibiotics to compete at their rate. So on the left here, I have a graph from UW Medicine, a presentation that was on this exact topic, and this graph is simply showing that in the x-axis you have the amount of penicillin that is prescribed, and these are all plots of different countries across the world. And so on the bottom graph is the amount of penicillin prescribed, and on the top is the amount of penicillin resistant bacteria there are, or percent there are of this one bacteria. And so it's found that pretty common trend that the more penicillin that was prescribed led to a higher rate of penicillin resistance. So it's pretty clear to say that we need to prescribe less antibiotics with the hope of making less antibiotic resistant bacteria. Yep. And the next is on the right is the amount of drugs that have been produced, or amount of antibiotics that have been produced. And so if you see in the 1980s and 1984, there was nearly 20 antibiotics produced, but in the last 2 years, from 2010 to 2012, there's like 1 to 2 antibiotics that were produced. And so the idea is that there's a finite amount of antibiotics that we even know about, and it's extremely hard to test all these different ones. I mentioned earlier that antibiotics utilize specific differences in our metabolic pathways, and it is a feasible thing to run out of these differences in our metabolic pathways, or for these bacteria to become antibiotic resistant. And so we definitely need to be more careful about how we prescribe and how we overuse antibiotics, because it seems we're running out of our weaponry, and we are showing bacteria all of our hidden techniques. So next I want to explain global health threat. So these infectious bacteria are becoming extremely daunting, and one thing I want to mention is that these bacteria can go global, and that they can be very, very scary. On the right, I have another screenshot of the UW Medicine presentation that I have a citation for in my final paper, and it explains the case of this individual named David, who traveled from India, and he had these two separate bacterial infections, and on the left of both these tables is the name of an antibiotic, and the letter R or I indicates R for resistance and I for intermediate resistance. So this individual had resistances to all these different bacteria, or all these different antibiotics, and this is essentially the list of antibiotics that could be used against the bacteria that are ailing him. And so the threat I'm trying to show here is that these things can travel across the world, because all an individual has to do is carry this parasite on a plane from one area to another, and then it's gone global. And that these things are very scary, because if we run out of antibiotics, we simply don't have anything we can do to stop these bacteria from running rampage. And so a world without antibiotics is a world that is essentially not feasible. And so with this, I want to conclude by just explaining various ways that I think we can go about reducing the threat of antibiotic resistance. The first way, it rests on the hands of medical professionals. I was mentioning, and I've probably overstated now, that anytime antibiotics are in the environment, that's a chance for resistance to be generated. So we need to be more careful about how we prescribe antibiotics. And we need to make it clear that we prescribe antibiotics and that the patients take for the full duration, for the idea that we do not release that selective pressure until every single antibiotic in the system is dead. And the idea is that If it doesn't survive, it can't get any stronger. Um, Next would be considering the option of taking an antibiotic cocktail, essentially, with the idea that if 1 in 10 million bacteria can be randomly resistant, the chance that one is resistant to two different bacteria, two different antibiotics, or three different antibiotics will be incredibly rare. And so giving two or three antibiotics can help ensure that all the bacteria die and none of them get resistance and survive. And then lastly, rather than thinking, oh, reduce the amount of antibiotics in the system, if we take vaccines to prevent infections before they even like become a threat, we can avoid even prescribing any antibiotics just because vaccines will prevent bacterial infections from the very start. So we don't even need to think about prescribing less antibiotics because we just won't even need them if certain bacteria die off because everyone takes vaccines. So those are the few ways that medical professionals can contribute to the fight against antibiotic resistance. Next is for our general public is to support politicians who support antibiotic research and more importantly support funding of the National Institute of Health. Um, as I showed earlier, we are running out of antibiotics and we need a lot more money and to do a lot more research on new antibiotics because otherwise soon we're going to be fighting various bacteria that are just going to be unkillable. And one issue in regards to funding is that when it comes to cutting funding, the NIH is always high up on the chopping block because it's not seen as a high immediate priority, but it definitely is, especially when it comes to funding research. And an unfortunate thing is that antibiotics are not money-making drugs. If you think about a lot of pharmaceutical companies, if you take, say, if you take a drug that you need to take once, or like once a day for like 2 years, and one single daily dose is $50 or some amount, you will be constantly paying that pharmaceutical company over and over and over again. But for an antibiotic, an effective antibiotic, you should only need a few amount of pills for a short duration. And the idea is that they're not going to make money because you're not a repeat customer, essentially. Their goal with antibiotics is to make you take very little and get out and not need them again. And so they're not money making drugs because you're not a repeat customer. And so we need more general funding for something that is a general threat to our public but is harder to fund. And so there are definitely politicians out there who do support this, but it's not seen as a current threat when it definitely should be. And next is in regards to agriculture, is that it's simply just an unnecessary threat. Creating more sustainable farming conditions and more sustainable systems for agriculture and the use of antibiotics in the system seems like such a simple way to help reduce the threat of antibiotic resistance. It would be better for the animals, better for us, better for everyone involved, and it boggles the mind that antibiotics are still being used in agriculture when it's such a clear threat to human health. And this is an issue that people are making way on. In 2006, the EU even voted and passed to ban the use of blanketing antibiotics in animal husbandry. And I use the term blanketing in the sense that they're just covering all livestock feed with antibiotics. And so the idea of blanketing being just fully covering. And so the fact that there is a way, there is a movement going is a good news, but we need to continue supporting this, not just in the EU, but also in the US especially. And with that, I just want to thank you for listening to my presentation, and I just want to help raise awareness for the threat that is antibiotic resistance. Please keep an eye out, and thank you for listening.